Alright, we're going to look at differential equations. Oops, excuse me. Differential equations. And we're going to also talk about growth and decay. And my students in my class, this is section 6.2 notes, and I'm going to start out by actually solving and determining what the general solution is for our differential. And so I'm going to start out like this. Our first one is given as y prime equals 2x over y, and what I'm going to do is first of all take this y prime and write it as dy dx is equal to 2x over y, and I'm going to break up the x's and the y's. So over here I'm going to have y times dy dx is equal to 2x, and then I'm going to multiply both sides by dx, and I'm going to have y dy is equal to 2x dx. And so what I'm finding is that general solution for this differential. And when I do this, this process is called separation of variables. You notice that the y is multiplying by the dy, the 2x is multiplying by the dx. These dy's and dx's should never be in the denominators. They should never be fractions. It should not be 1 over dy or 1 over dx. They should be kind of in a whole number form, if you speak. So I'm going to take the derivative on this side. I'm going to take the derivative on this side. The other thing is, if you can, y should be by itself. It most definitely should not be multiplied by anything. If there is a constant that's being multiplied, it should be moved over here by the x. Alright, so I'm going to take the antiderivative of y, and that's going to be 1/2 y squared plus c1, because I'm going to have a constant, and that's going to equal the antiderivative of 2x is x squared plus c2. Alright, so now I'm going to figure out, get y in terms of x here. So I'm going to subtract c1 from both sides, but if you recall, c1 is a constant, and it's going to be taken away from c2, which is a constant. And what is that going to give me? That's going to give me what we say is a constant. So now I have 1/2 y squared x squared plus a constant. Alright, where that constant come from? It came from c2 minus c1, which is a constant, minus a constant, which gives me a constant. Now I'm going to multiply both sides by 2, and I'm going to get y squared equals 2x squared plus, now I'm taking and I'm multiplying 2, which is a constant, times c, which is a constant, and it's going to give me a constant. And my last step is to take the square root of both sides, and so I'm going to have plus or minus the square root of 2x squared plus c. So this is my general solution to this differential. That's what we say. So if I would put in my y value and my x value in here, it should simplify. It should simplify into this expression. Alright? Alright, let's take a look at another one. And I'm going to again have y prime is equal to x times 1 plus y. And this means I have dy dx is equal to x times 1 plus y. Again, I'm going to separate them. And this whole quantity, I'm not going to multiply through by x. I'm going to take this quantity, I'm going to divide both sides by this. So I'm going to have 1 over 1 plus y. I'm going to have dy, because I'm going to multiply this side by dx too. Oops, I just wrote dx instead of dy. Got that fixed. Oops, I got to do it a little bit more. Alright, I'm going to have dy here is equal to x dx. Now I'm going to integrate both sides because it's an operation. I can do it to both sides. And on the right side here, I'm going to have 1/2 x squared plus c. On this side, what I'm going to have, if I notice this is a quantity of the first power, I'm going to have the natural log of 1 plus y. Now, if you notice, I didn't write plus c because I'm going to end up subtracting that c anyway and combining it with this c, and it's going to be a c. So I'm going to save myself a c. Now, again, I want to get y by itself. What does this mean? Well, this means my base is e. My exponent is 1/2 x squared plus c is equal to 1 plus y. Now let's examine this a little bit closer. This is e to the 1/2 x squared times e to the c power. If you recall, when the bases are the same, you add the exponent. So I can break them apart this way also. Now, e is a constant. It's about 2.718 blah 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 blah. I'm raising it to a constant. That's going to give me a constant. So I'm going to write c out here, e to the 1/2 x squared. And then I'm going to have that equal to 1 plus y. And I'm going to subtract 1 from both sides now. And so I'm going to have c to the 1/2 x squared minus 1. That's equal to y. Alright, I'm going to do another one. I'm going to clear the screen. The example I'm going to give in this case is dy. I'll write it in this form right away. dy dx is equal to 4 minus y. There is no x. So that means I'm going to have dy is equal, this is in parentheses, 4 minus y times dx. Well, I want to get rid of this quantity, so I'm going to have 1 over 4 minus y dy equals dx. I'm going to integrate both sides. Now remember, this is like 1 dx. So the antiderivative of 1 is x plus c. If you take the derivative of this, I should get 1. Now what do I have here? Well, I think I got the natural log again. And if I'm not sure, I'm going to make u equals 4 minus y du dy. Dy is equal to a negative 1. That means a negative 1 du is equal to dy. So now I can substitute, and I'll have a negative 1 over u du. Remember that negative du is dy right here. And this is going to be the negative natural log of u. So up here I'm going to have the negative natural log of 4 minus y. Okay, and I only did this to figure out what this integral is. Now I'm going to divide everything by a negative 1. And that's going to give me a negative x, but c divided by a negative 1 is still c. So I'm going to get e to the negative x plus c equals 4 minus y. That's an exponential form. Now if you recall, this c is going to end up being a constant that's going to be in front anyway, because it's going to be e to the c power. So now I have c e to the negative x equals 4 minus y, which means c e to the negative x minus 4 equals a negative y. So I'm going to multiply everything by negative 1, but negative 1 is a constant. So I'm going to end up getting c, because a constant times a constant is a constant, plus 4 is equal to y. And that's my solution. Alright, I'm going to do one more of these type. Right here, again, I'll use y prime in this case is equal to square root of x times y. So that's dy dx is equal to x to the 1/2 times y. That means 1 over y dy is equal to x to the 1/2 dx. I'm going to integrate both sides. That's going to give me the natural log of y is equal to, well, I got to add 1 to that. I'm going to get 3/2. That means I'm going to have 2/3 out here, because I'm going to multiply by that reciprocal, plus c. And now, so I'm going to have C E to the 2/3 x to the 3/2 power is equal to y.